Hello and welcome to TidyX episode 121. TidyX is a screencast where we explain how our code works. My name's Ellis Hughes.
And my name's Patrick Ward, and today we are going to solve a real world problem.
Oh,
Yay. So we
yeah.
got a email from a viewer, which we love, and we were asking for in this kind of like tidyverse data cleaning, data engineering sort of um, segment that we're doing. And so this individual is a researcher, and he said, I've got some data that was given to me from some clinics that I work with,
This is
and
simulated.
this is
This is not
simulated
real,
data.
to be clear.
These are not real. It's made up two rows of made up data. So he said, I've got some data. I'll send you some kind of fake two rows of what I've got, what was given to me. We'll call it data collected in the wild. And I'll send you two rows of what I've got, and I'll send you two rows of what I want. And we kind of hinted at this. We've talked about it a little bit last week. We've talked about it in previous episodes. A lot of times when people collect data in the wild, especially if it's time series data, practitioners and they tend to not think about how the data needs to be structured for analysis. And so they collect it in this sort of horizontal, wide format where every new observation kind of goes across the Excel sheet or whatever tabular type of data
Mhm.
collection sheet they're using. And
It
so
makes
that's what
perfect
we,
sense when you see it, though.
it
Like
does.
as
Yeah.
a
Yeah.
as a person, you look at it like, well, obviously, this goes to like these three group together, and then this is
Yeah.
telling me information about what these two are. The columns here are indicative, like are telling me more information about what this test is.
Right.
So, like as a person not doing data analysis, makes perfect sense.
But when you go to analyze it, you need it in a different format. So the what I want format is in tab two, which is you can see it's in this like long skinny format. I'm going to call it long esque. Like the true long format is like one observation per row, really long down the page. This one we have it's like a long wide format. We have a long format in that we have one observation per row, but it's wide in terms of we have multiple bits of information that are kind of traversing the page for each of those observations. So if we go back to the original data, let's just kind of unpack what's there. We've got one row per patient. Looks like in column C, it's telling us that column B tells us this patient had some sort of surgery. Column C tells us how many weeks post-op they are to do their first test, which is in column D, which is a isometric quad test. So this is like a strength test. And then in column E and F, this begins collecting values. So we see test one peak RT is right side, and LT is going to be left side. And then column G is basically the analog of column C. It's saying, hey, this is post op test two. And in test two, patient ID one was 12 weeks post op, and patient ID two was 40 weeks post op. And then column H and I are the corresponding right and left strength test outputs for that test. And then column J is post op test three, where patient ID is at 22 weeks post op and patient two ID is at 44 weeks post op. Patient one did not test that date, and patient two did at that time, and they tested 153 and 201. And this carries on for probably who knows how long. This is obviously just example data.
Mm-hmm.
So we're going to read in the data from the Excel sheet, and we're going to get to work with this to try and turn it into that what I want tab. I'm going to read in both so we can take a look at them in R. So we're going to run Tidyverse, and we're going to run the read Excel package, which allows us to read in Excel files. In particular, we can specify what kind of sheets that we want to read in.
Mm-hmm. Yeah, here's just the path to the Excel file. This is just so it works because we're gonna have the data, in our GitHub repo. So this
Mm-hmm.
should work if you download it and download the entire repo. You may need to change this path though if you just download the script and the example data yourself to test it out on your own.
Yeah,
So,
or you could put in a file choose inside of read Excel if you just plop it on your desktop or something like that.
yep.
Um, Okay, so reading what I've got is the original data. That's going to be sheet one, and what I want is going to be the sheet two. Okay, so we can take a look at these in R. You can see that these are the exact same things. We've got what I want and what I've got. In the what I want, um, the researcher has only looks like specified the test outputs on the right side. We're going to just go ahead and do both because you may as well just collect both in one column next to the other. It's
If you're writing the
no harm, no
code,
foul.
you're writing the
Yeah, you may as
code.
well do.
It doesn't cost you any extra to handle it purposely. And
Exactly.
this is based on what we're understanding this what we want output to be.
Correct. So we're going to do this in two ways. I did one way, and then Ellis did a second way. Both ways are going to work. Ellis's is a little shorter, but it's going to require knowing sort of the ins and outs of pivot longer and some of the details around regex expressions. Mine is going to be a little longer, but it's a very like direct A to B type of approach. You'll be able to see how I got there. Everything in rows 19 to 27 are simply notes that I wrote down for us after talking with the researcher to further understand the kind of what I want output that he was looking for. So we've read in the data. The first thing I did was just run a little glimpse on the what I've got. And I just did this because I noticed that some of the columns, since it's Excel, get read in as characters if they had NA in them. So one of the things I'm going to do is a little bit of cleaning to make sure that those are numeric. And that's how I'm going to start this script. We're going to do a right side, and then we're going to do the exact same things for the left side, and I'm going to join them together. So what I've got, the first thing I do is I pipe in this select minus type. Type, I'm assuming based on the example, is always going to be isometric quad test. So it's sort of redundant. We know that it's isometric quad test. So in order to get this column out of there so it doesn't trip me up, I'm just going to drop it. If we needed it, I'd have to work with it some other way. Then I'm going to do this mutate. So I'm going to say, hey, any of the columns that start with test, which we've noticed in our glimpse have some character values in them. I'm just going to say, hey, kick these out to be numeric. And R is just going to bark a little warning at me when we run this. It's going to say, hey, warning, there's some NAs here. But that's totally fine. We expect that to happen. So R is doing its job, and it's just telling us it's doing its job, and that's totally cool.
And you could throw a suppress warning in there, but it's actually kind of potentially a good thing to leave the warning in there. That gives you, if you start seeing this change, and you see 5 warning messages about, hey, I'm converting numerics or NAs were coerced. You're like, wait a minute, I was only expecting 4. And then you can start to investigate your data. So you can suppress them, but there's some information potentially gained from leaving them in there.
Yeah, I'd prefer not to in this case, especially if you're working with data more than 2 rows and you want to make sure you keep track of what's going on.
Exactly.
So once I've got those into numeric, I'm going to do my first pivot longer. And this is going to be a series of pivots here. So this first pivot longer, I'm basically going to say, hey, the columns that I don't want to pivot. So I'm putting that little negative sign in front of the C, the concatenate. I'm saying the columns I don't want to pivot. I don't want to pivot patient ID. I don't want to pivot surgical limb. And I don't want to pivot anything that starts with the word post. That's telling us where those post-op tests took place at the time. I want to keep those, and then I want to pivot everything else. So all of the values in those test columns, I'm going to pivot those out. And what I'm left with is this column called name, which has all of the test, that's going to be like test 1 right, test 1 left, test 2 right, test 2 left, and the values, the strength tests for the individual. And you can see that right now, this isn't in a great format because I've repeated a ton of rows because I didn't pivot out post-op weeks 1, post-op weeks 2, and post-op weeks 3. That's okay. We're going to handle those in a second. The reason I did this first pivot is because I wanted to create this little indicator value that said, hey, if this in the name column, look in the name column, and if it contains the string underscore RT, call it right side. And if it contains the underscore LT, call it left side. And in doing that, I can then filter out only my right-sided tests. So now I'm dealing with just the right side as the name of this data frame that I'm about to create indicates. So I filter out right equals right, and now I've got only right sides. And I'm going to rename that right test column. I'm going to rename that I'm going to rename the volume column right test because this is only the right test strength numbers. Okay, and then I'm going to drop that test side column because I don't need it. It was just there for the purpose of doing this filter, and we're one step closer to getting the data set that we want. Now I do my second pivot. So now I'm going to handle the post-op columns. I'm going to say, hey, any of these columns that start with post, column post-op, and take the values in the weeks post-op and throw them into their own column. So if we run all of that, we end up with this, which says, okay, cool. So now we could see, looking across, we've got patient ID, surgical limb is right. We've got test 1, right side, 109, weeks post-op 8. We've got test 1, 109, weeks post 12. So we still have a problem. We have this repeating, this repetitiveness. And we're about to handle that right now. And the way that we do that is we're going to do group by patient ID. So remember, we have 2 patients in here. I'm going to do a bunch of parsing. So in that test num, I'm going to create this column called test num. And in that column that's called name, I'm going to snag those numbers. Those are test numbers 1, test number 2, test number 3. And then in the post-op column, I'm going to snag those numbers because those are the same corresponding numbers. Post-op 1, post-op 2, post-op 3. And then if you looked at what the researcher wanted, he didn't want it to be weeks post-op. He wanted weeks post-op to always start at 0. So I just basically said, hey, take if the person was 8 weeks post-op to start, we're gonna subtract that from their starting value. So that's what I did in this column. I did weeks post-op minus weeks post-op 1, which is the first value. Ellis will do this with the min in a second. You'll see what that looks like. So the way that we then remove this doubling is now that I have the numbers parsed out, I'm just going to filter to everywhere that.
Show you what that looks like real quick. Yep. All right, so then you can see here, this one is from this one here, and this value is from this value here. And when they match, that's the record that we know is the same, or that we know that the post-op value corresponds to the right test value.
That's right. Yeah. So I'm going to filter to equal that, and then I'm going to drop the weeks num and the name columns because they're redundant. They don't help us with any information. And now we have the right side, and it's now as easy as doing the exact same. I basically copied and pasted this down, and all I did was change my indicator to left, test side equals left, and I let it run, and now I have the left side. And now I just make a simple join. I full join. R is going to find the variables to join on for me. I don't have to specify anything because I did name the columns the same with the exception of left and right test.
And it does spark out a nice thing where if you do want to have it not complain anymore, you can just copy that string in and just
you could give it the by. Yeah. Mm-hmm.
There you go.
And it'll join on those specifically on those columns. I do a little relocating to get everything kind of in the right order because when we joined, it didn't really, it just joins them, right? It doesn't put them in any order. So I want the right and left side next to each other. So if we join, we have our new data frame, and this looks like what we want. The only difference is that I've also added a left test for the researcher as well. So now they have left and right. And maybe if they wanted to do an analysis on the difference, we can do a little simple statistical test just for fun now that we have the data in our in the way that we need it. So just run a little silly linear regression, and there we go. And that's a way of getting from the originally collected data to what the researcher required. So now Ellis has an alternative approach.
Yep. So basically what I did is I know that there's a pattern in the naming. And the naming of the columns means something, so let's use that for our advantage. So the first piece that I do is this first section is the same as what Patrick did. Like he said, type probably seems like it's going to be repeated. If it doesn't, let us know, and we can go and redo this with keeping test in there. Then we're going to convert the values that are character into numeric because we know that they should be numeric. The first thing I do is I'm going to use this function that we talked about last week, rename with, which allows you to specify a function that will be performing some renaming. And what we know is if you look at the data here, really post-op test, like this post-op doesn't really give us more information about it. What we need is to match up this portion. This is the repeating value. So this is telling us this is, you know, test 2, and the value that's contained there is weeks. This is test 2, and the value contained under there is peak RT. And so we know there's a pattern in there. And post-op, the word post-op is not giving us any additional information. So we kick it out. So I'm going to go through and go any column that starts with post-op. I know post-op means nothing. Let's remove it with the str remove function from stringer. And so now when we run this, I haven't done any reordering or changing of the columns in terms of order or contents, but now it's test 1 weeks, test 1 peak RT, test 1 peak LT, test 2 weeks, test 2 peak RT, test 2 peak LT. And so when we have this pattern that we can use to our advantage when we're doing our pivoting. And this is using some advanced pivoting techniques that exist that I think it's kind of easy to just gloss over them and just do a pivot longer and move forward. But what I know is that there is value in the column names themselves, and we can split that out. So I'm going to say I want to pivot all the columns that start with test. So this is test 1, test 2, test 3. Names prefix is saying hey, there's going to be a prefix ahead of all these columns that means nothing. Don't worry about it. Get rid of it. Once again, test was repeated. Test doesn't actually provide us much more information. Let's not keep it. If we wanted to keep it, we just remove the test prefix here, and then no harm, no foul. The next piece is, so there's 2 functions in pivot longer that you can use. You can use names pattern and names sep. Names pattern says identify the pattern using regular expressions of the column that you want to split out, and using parentheses, identify the groups of values you want to keep together. And the number of groups you have needs to correspond to the number of groups in your names too. And so here I'm saying I have 2 groups in my columns here in the pattern that I want to keep. One is going to be test num and one is going to be record type. In the order of which the groups are correspond to the value that it'll go to. So let's think about this regex for a second on test peak RT. So what we're saying here is test, get rid of that. Next I'm saying my first group that I want to keep is number, and any number of numbers. So here we only have 1 through 4, but if it went up to like 100, you can't just do //d because that'd only keep the first number. Next, outside of my groups, I have an underscore asterisk. And that means there might be an underscore, there might not be. And the reason we want that is for this weeks group here. So I don't want to keep this underscore in there, but I do want to keep this underscore in there, which is why I put it directly after the digits. Then I say the rest of the column, I do want to keep that. That is telling me information as well, and that's actually the record type. And so it's going to split out these columns, so I keep the number and then the string after that. And it'll drop, if an underscore is right after that, it'll drop it. So when we run that, we now have a data set that looks like this, where we have our test number being 111, our record type being weeks, peak RT, and peak LT. So this is already basically parsed out for us. So the next thing we do is we do a pivot wider because we don't want it in long format, we want it in wide format where we read across and go, for week 1, peak RT is this, peak LT is this. So we just use a pivot wider now. I'm going to rename them to match what Patrick had. So I'm going to rename peak RT to right test and peak LT to left test. I'm going to do a group by patient ID because we want to calculate then the weeks post-op, which is the first visit they have, and then subtract that from the rest of the visits. And so the reason I'm using min is I just didn't trust that necessarily the order in which the data got organized was necessary. Like things could have gotten messed up, and so I didn't want to just go with give me the first record. You could do that in this situation; it does work out. And then if you really wanted to
as long as you know, as long as you know the data is in the order that you want it. Otherwise, you have to do it the way that I had it. You'd have to do an arrange. If it was out of order, you'd have to arrange by test
And
number or something like that.
and then if you really, and then I
Yeah.
ungroup to remove my groups. And then if you really wanted to be persnickety and make sure that the data that came out of it, you could use
Yeah.
in a range and say by patient ID and then by weeks post-op. And that'll then make sure to sort it all together. And then we get the same data set. I mean, it's slightly different just because they're, we have ever so slightly different approaches. I'm printing these two out here. So surgical limb is the same, patient ID is the same. I don't have post-op because it was just an artifact from the way that you'd approached it. But
Yeah,
we have
we could actually drop if we drop that column. I think it's
uh,
pretty much exactly
yeah, I have weeks as
the
well
same. Oh,
retained.
you kept the actual weeks and yep.
Yeah.
Yeah.
So we ever so slight differences, but the
Same. Yeah.
fundamental things that we actually care about, which is weeks post-op, right test, left test, patient,
Yep.
surgical limb, test num. Those are all the same.
All the same.
And we can confirm this by throwing it into the linear model, and we get the same results.
Yay.
Hey, so there you go.
And the arrange at the end of that to make sure that you're arranged by this is like we only have 2 rows of fake data here, so this isn't a big deal. If you were dealing with, let's say, a large time series data, maybe this is a researcher working with multiple hospitals all turning in data on patients, and it's time series data. The most important thing you can do before you analyze it is put that time series in order by patient. Otherwise, you will get
Chaos.
some weird outputs.
Chaos. Don't do that. Always check your
Totally.
data.
Yeah, totally. But yeah. So
There you go.
that's some data in the wild. Thanks to our viewer who sent this in. Also, super thanks. Like if you know again, we're doing some tidyverse data engineering type of things right now, and if you want help, this was a great example of how to kind of ask for help. Is here's an example of what I've got. Here's what I'd like it to look like. Here's like 2 to 5 rows. Can you help me out?
Mm-hmm.
That really helps
Constrained.
us.
Yeah,
That really
constraint.
helps us know what we're working with versus just trying to send an email that explains it in text. And it's like, okay, I kind of get a sense for what you want, but I don't really know. So examples of what you got and what you want, always with fake data, is super, super helpful for us because then it allows us to kind of get going
Exactly,
without too much.
and then
Yeah.
we have a target to go towards as opposed to going, well, looking at this data, I think this is how I'd want to organize it, but that's not necessarily the question. Like the way that we look at the data may not be the same way that you do in terms of the question you're asking really is what determines the shape of the output that we're trying to
Yeah,
generate.
totally. Totally.
But yeah, so with that, that is episode 121 of TidyX, doing some work with real data, doing some pivoting, doing some relocating, showing you how to work with some fun advanced pivoting tools.
Cool.
As always, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick and at tidy_explained is where the both of us are on Twitter. Tidy.explained@gmail.com, where you can drop us an email with an attachment of your fake data if you'd
Yeah,
like some
love hearing it.
if you'd like us to work on something live on an episode. And then most people get into contact with us on the YouTube page, like and subscribe, drop a comment below. If you like the work that we do and if you feel like it's helped you and you'd like to contribute back to us, we do have a Patreon page. We're always appreciative of anything that anyone would like to give.
Exactly. Thank you all so much, and keep on exploring your world.